No rotation. We have no rotation. And why don't we have a rotation? Why? No. I'll put this here. Maybe the origin point is not good. Where do we set it? Rotative rubber. X, Y, Z. X, Y, Z. Here might go. It's possible. It's possible that this is the situation. So we see. Let's see. Okay. We're starting to see movement. You see them? Okay. Oh, you see them? They're rotating, all right. Look at them. Look at the blockers. Oh yeah. Look at them. Yeah. See them? Okay. So this is the function that we were gonna use. A method. Rotate around. Rotate around. Okay. So what's the issue here? First of all, uh, uh, we get a pause. We've got a pause. We have to solve that pause problem. Uh, second, the origin. Yep, we've got to solve this. Rotative. So y. So we adjusted the y distance. Now we must adjust the x distance. We might just we have to readjust the y distance. So this is one issue, and let's solve the issues with the with the poles. So let's analyze this a little bit. So for the first, if checks if the angle overlapped the 360 degrees. If it did, we reset the angle. Okay. Else if moves 90 degrees. Oh, now it stops. Oh, now it moves. Now it moves 90 degrees. Oh no. Uh-huh. So what's the problem here? The y, could it be very, very big? Relative y. Oh no, no relative y. 0, 0. So, huh. If it's 0, 0, how the hell did we get such big differences? 0, 0, 0, 0. How the hell? Something weird is going on. So we got our relative position 0 on both blockers, and how the hell are they positioned so high in this world view? And they were supposed to be exactly at the level of these barriers right here. It's very weird. Very weird. Let's just let's debug it a little bit. So debug log eh, why? Okay. Okay. So as you can see, it's 0. Of course, it's 0. Of course. But it's very weird. So where is the blocker? The blocker here. Okay. So we have the barrier here. Look. This is it, the barrier. Okay. It doesn't matter that we don't have the X center position properly set up. At least we have the Y position properly set up. So why is this blocker? You see? So down the tube. I mean, it's very bizarre. Very bizarre. That's why game developing is fun, because even though You set up a very small world with basic physics and basic motions. Uh, when you try to code it, it always behaves very strange sometimes, and it never ceases to amaze you. Why the hell is it positioned here? If okay, so let's see, where do we set up its position? We set it up. Um, Compute blocker codes. Load. Oh. Okay, so the X position is good. The Y position now. Body transfer position. Robin radius sec. Okay. So this Robin radius is, where do we set it up? I guess set up really accurately, if I remember well. Rotative Robin. Okay. Robin radius. It's not. So this is the problem. I didn't readjust. Okay, let's test it now. This should fix it. It should. Okay. Good. Oh. Should reset the game. Okay. Good. You see? Now we're talking. Now we're talking. Okay. So they rotate around a certain point, the middle of the barrier. Let's solve the pause issue. So it pauses. Why does it pause from angle to angle? So map edges. So we have this code right here. So let's paint. Let's paint. Paint. We now have paint. Okay. So we have the basic trigonometric circle. No. Let's make it pretty. A pretty little circle. Okay. Good. We have a line. Okay. So this if checks if we are here. This first quadrant, and we have motion. Rotate. Then if it's here, okay. Oh, no, nope. We have. Huh. Not quite it. Yep. So the acceleration we're talking about Q1, Q2, Q3, Q4. Allergy. It's quite a few weird plants here in Bora Bora, Costa Rica. So this is not quite, but this. No, 0.45. Yes, 0.45. So we have oh, 0.45 here, 45. Mm. 90 here. One hundred and 35. 135. Oh. One hundred and 80. Okay, so this is the angle. Okay. So first we check if we're here. We are. And no set, but go around line. So we have 180. Oh, 180. 2 to 5. 2, 5. 2 to 5. 207. 70, yes. And 315. Oh no, 270. 225, 225, 220, 315. Something's wrong. 45, 90, 130, 185, 180, 2025. Okay. 217, 315. Okay. 217. 115. Okay. And this is 315. 360, or basically 0. Okay. 0. So we're back to 0. Okay. So we check this one also. Okay. So transform it also. Good. Then we check 270, 225. Okay, we rotate it. 270, 315. Good. 315, 360, and we forgot to set it here. Okay, so let's see. We must have, we should have a continuous movement now. I should have, let's see. So we have no stopping, no more. Okay, good. Good. The movement, of course, it's very slow because we have a small frame rate. Why do we have a small frame rate? I don't know. Because of the streaming, of course. Streaming. So memory. We need more RAM. More RAM. We need more RAM. AMDFX. Okay. So okay. So this is the function we will use to rotate a game object around a point that is not an axis of the object we're trying to rotate. Let's see the pivot point. Let's see if we have I don't have it drawn here. So it's it's a it's a simple function. Rotate around the origin point, the pivot, the axis, in our case the z-axis, and the speed, of course. Okay, so we have these. But so we'll just have to set up all these other blockers, init functions. So we have them set up properly. And this the next thing we have to do and study the all the Java code a little bit, so we remember what exactly we did in this game. So it's all it's going all well. We're starting to get the blockers moving. Translations, rotations around own axis, around pivot points in other planes. We gotta set them up all now, and start playing with the settings a little bit, so we can adjust the old coordinate system that we used in libgdx, and readjust those variables, those constants into our new world view, the Unity world. Um, and after that, after we solve all the mechanics, motion mechanics of these blockers, we'll have to um, work on the spaceship, on its mechanics a little bit. So we'll have to solve its movement. We have a little bit of issues right now. I don't want the camera moving so much with the spaceship, so we'll have to use the modify the Cinemachine settings a little bit to modify the damping and reduce the camera movement. We want just a slight motion, a follow up of the spaceship, but very slight, something that is just pleasant to the eye and nothing more. Uh, we have the movement, make the movement a little bit more smooth. We have the to make the thruster, this thruster, uh, expand as we accelerate. We have to make it bigger, as if more energy uh, comes out of the exhaust pipe of our spaceship. Then we will have to make it shoot laser beams, simple sprites in the beginning, but after we'll finish the game, we'll add we'll create a little bit of um, mm, shader effects, and the sky is the limit when we'll start using shaders, make something beautiful. Hopefully we will do art. um, so basically this is a remake of our old game, but much better remake, a much better game than this old one. Much better game. Okay. uh, uh, okay, let's stop this a little bit. So let's check the code a little bit. Okay, so we have this type of blocker. Skip it. No, not. So we have this type. Okay. Round robin. Expand speed. Ah, yes. I think that. So we have the relative positions, length expansion, speed, and the radius. Okay. Robin radius. And this we have to divide, I don't know, with our readjusting distances. Okay. So we have this one. Good. Uh, okay. We readjusted the. Uh-huh. Okay. Good. Oh, but also this. I mean, ambrosia. Let's see. Google Translate. Let's see. How do we call this? Ambrosia. Rosier. Ambrosia. Plant. This has been killing me the last few years. Ambrosia artemisifolia. Look at this plant. Is causing havoc around the world. Ragweed. Ambrosia trifida. Ambrosia artemisifolia. Common ragweed, cornel weed identification. Huh. Allergy. Oh my god. Anyhow, let's get back to game deving. I just realized that I didn't readjust my I readjusted Y positions or X positions, but not all, and they all need to be readjusted. So let's modify it. Okay. Okay. Good. Okay. Also this. Okay. So YX, the length expansion. Okay, so this is a simple bouncer. Okay. Then we have the rotative bouncer. And this was what? A round robin. Okay. We also have to change the order inside the switch from the most simple one, the bouncer and the rotative, to the most complicated one. Makes the code more simple to understand and read, but we have time to do that. Rotative bouncer. No. Deploy distance. Maybe, yeah. Let's see, bouncer. Robin. Rotative bouncer. Deploy distance. Yes. Deploy distance also. if we adjusted the bouncer, we must adjust the rotative bouncer and deploy counter, deploy distance, deploy distance. It has two. mm, Deploy distance. So it has two. So deploy distance can generate. Okay. Okay. I just do this one, and this one. Okay. A rotative robin. So this is the one. Moves around on center axis Z and around point on XY plane. And the same also on the Z axis, but radius, rotation can generate no. Okay. Good. A Robin bouncer. What does this do? I don't remember. Moves around on center. This one and point action, and this one a Robin bouncer. Robin bouncer. I don't remember what this done. Oh, we will find out. Do you like Java or do you like C Sharp? It's like asking, do you like peaches or do you like oranges? Well, I like them both. Why shouldn't you like them both? Um, oh, okay. But what did this button do? Like Didi used to say. What's this button? What's this blocker do? The Robin bouncer. It's a robo. The robo. What did it do? Uh, what did it do? A robo. Moves along x-axis and around point on xy plane. Okay, of course. Is all Java code is very readable, you see. Very good, nicely arranged. not on long lines. You can read it with scarce movement of the eye. Mhm. So this is wooden bounce. Okay. Oh. Mm. All right. This one too. This one also. Okay. Translation X. I guess we have to move this also. But why did we use that? I don't remember. What for? Okay. Station. Replay. Distance. Replay distance. Maybe this. Let's read them one more time. Still forward trans. Maybe here also. Yeah. Rotational sense. Okay. Rotation sense. Trans-X. Okay. Deploy data. This one. I don't know what this one is, but it's probably another translation upon the X and Y axis. Deploy distance, good. Readjusted the expand speed, good. This one also trans-X. Trans-X is Robin radius, trigger angle. Good. Okay. Good. So we have our load blocker function, which behaves quite well. Okay, code is nicely arranged, readable. Let's make it more readable. So good. Uh, okay. Uh, Okay. Complete local borders. Um, uh-huh. This is the rotation pivot. Stuff. So the rotation pivot x, rotation pivot x, rotation pivot y. That's I should put those are a radius. Okay. So this is the rotation point around the blockers used to rotate around their own axis. The origin should be the middle of distance between the electron. Okay. The origin is just the middle of the barrier. So we have two pivots. One is on the barrier right here. So blocker can rotate around this, and it can change left, right, depending on the transx variable. We can slide it along the x-axis however we want, and besides this we also have uh, a rotation pivot of the blocker that's used to rotate the object around its own axis rotation. But you don't need to do this here because Unity detects the pivot point of its objects automatically. It's, it has them set up already from the editor, so we don't need to set them up by code. It's all done automatically by Unity. So we will not use this. We will use this. Start line and end line are the vectors responsible for the at the beginning. Uh, start line is here, end line is here, the middle of the blocker. When the blocker starts expanding, okay, start line will detach from end line, and these two vectors will basically represent the start and the end of the laser mesh line. Things will get more interesting once we start to write the code for these meshes. We will be coding the quads, their angles, the intersection of the meshes. That's when things will really start to get interesting. Once we hit these blockers with our spaceship laser, uh, they get blocked at certain angles and they start expanding and blocking these red barriers. So we can pass them without dying. Uh, it's a fun game to code. It's not just basic, just not a basic shoot 'em up space shooter. Okay, so when we're starting to approach these barriers, we will get electrocuted. Our spaceship will start to lose health. Yes. Okay. So rotation pivot, we have two of them. Rotation pivot and origin. Start line and end line. This we will use, of course. Rotation axle Q1. Okay, this we need. Current direction. left circle origins. These used to be the collider circles, but since Unity uh, has the colliders already set up in the editor, we don't need these anymore. Translation acceleration, since this is a Robin bouncer, we also have yes. Okay. Yep. You see, here we set up the blocker. This is the old Java code. We set up the blocker origin, that is the initial position. Yes, let's see what did this function did. Google. So we have set origin, sprite, and a libgdx. Okay. Oh, this is libgdx. And community documentation. Okay, Java docs versions. Don't we have a search function here? No. Java doc.io. Open source projects hosted on Central Maven. Wiki. So this is it. Set origin. No origin. Sprite. Maybe we didn't have an origin. Set origin. Blocker. No, it's the method used by the sprite set origin. What is it? Sprite. Yes. The origin relates to rotation and scaling, as described in Java docs. No, not working. This is an old link. 2012. Oh my god. 10 years ago. 10 years ago. Oh my god. Time flies. Okay. This is it. This is the function, the method that sets the position of the sprite, its center, of rotation and scaling and position. Now yep. So, alright guys, we managed to get this blockers rotate, which was my main problem yesterday, or a few days back, and you also need to make them rotate on their own axis, and the game mechanics of these blockers are starting to... Oh, there's a problem. Of course there's a problem. Yeah, we have a problem. The barriers, something's wrong with the barriers. Oh, they don't electrify. Something's wrong with them. I don't know what. The lightning bolts, I don't know what happened to them. The lightning bolts don't bolt anymore. Huh. Why? Ah, they do now. It was an error. Just a slight error. Unknown error. See if you pause and start again. So they work. Okay. They work quite good. These are just simple sprites, rendered sprites. But my main goal after I finish the game is to make them using shaders. Right now they're just simple lightning bolts. I created them with Photoshop. I don't remember quite well the technique I used to, but you can create them as simple PNGs in Photoshop or any similar 2D design tool like Photoshop. So the next days we have to write the code for all our blockers or all their mechanics. We have 1, 2, 3, 4, 5, 6 types of blockers. We have to write the mechanics, check if the script loads their settings, position, rotation, accelerations, etc. We gotta check if those accelerations um, are working as supposed to be working. They're supposed to be working. We must check if we multiply it by time delta time as we're supposed to multiply. And the next phase after we solve these issues, which are starting to be solved quite well. You see, we have movement here. We will make the spaceship shoot its laser beams towards the blockers, and it will be a simple tap or a click of the mouse. Uh, we won't have to move it necessarily left or right to get into to the position to shoot the blockers. No, now we will just click them or tap them on the mobile screen, and it will shoot its laser beam at the necessary angle. So no, the the player the player will have to uh, only tap or click at the right time, so the blocker will be hit in the correct position, so that it intersects with the barrier and blocks its energy beam, its godlike, powerful lightning bolt beams, so we can pass them with our tiny little spaceship towards on our way towards our destination, which is probably far out of the solar system. Okay, yep. Okay, so little by little, okay, we have to write the code for the movement of all the blockers. That means setting up their initial positions, rotational speeds, translation speeds, etc., etc. You have to verify that's okay. Mechanics accelerations, we have to check them. We have to check delta time multiplication to see if those accelerations are indeed accelerations, if they work properly. We have to test it. Um, um, then if we got the mechanics of the blockers quite in order, then we'll have to work on the mechanics of the spacecraft, make it shoot, and this is when we get things start to get interesting, very interesting, because interaction will enter our game, because these blockers will start expanding. They will interact with the beams of the barriers. They will block the bolts, the lightning bolts, and some weird objects and uh, mechanics, and uh, and a little bit of basic trigonometry and linear algebra, just to get the taste of uh, the flavors uh, of your brain taste buds uh, activated. For you and for me, who have been out of touch with this thinking patterns in the last few months, years. Okay, this will be quite good and welcomed training. So this is it for today. Thanks for watching, and see you the next time.